Whenever we talk about memory, we tend to talk about it in terms of being similar to computers in many ways. And that's because the major theory out there that explains how human memory works was actually developed by, modern computer scientists. So now what I'm talking about is called the information processing theory. And the whole idea behind this is that there are three distinct processes that occur whenever we are, dealing with new memories or old memories. And those processes are encoding, where we transform information into a form that we can store in memory. Storage, which allows us to keep those transformed memories in our mind for virtually forever. And retrieval, which will allow us to bring those stored memories back out of this long-term storage. Now, the most popular model of memory out there is called the Atkinson-Schiffrin three-stage memory model. And here's what it looks like. So incoming sensory information, sensory stimuli from the environment, first it's held in that sensory memory for just a few seconds. Now, depending on which sensory system we're talking about, it'll be held for a little bit longer or a little bit less, but it's usually only a couple seconds. Now, by selectively paying attention to certain kinds of information in our environments, we can then transfer that information from this sensory memory to short term. And if we can transfer it to the short term, it'll stick around for about 12 seconds. So you can keep something in your short-term memory for about that long. Now, if you want to keep it in there for longer, then you can take advantage of a subcomponent of short-term memory that's called working memory. Now, working memory is a part that just basically allows you to manipulate and rehearse and just interact with your short-term memories in many different ways. But like I said, you'll only be able to keep information in short-term memory for a relatively brief period. If you want to keep memories around virtually for the rest of your life, then you need to get them into that long-term memory. And the way you get them into long-term memory is that, encoding I was talking about earlier. You need to transform those memories into a form that you can store. So if you do encode the information in short-term memory, you can move it into long-term, where it's going to be stored. And then if you want to remember something that happened to you in the past, if you want to, remember a long-term memory that you have, then that's where the process of retrieval comes in. So retrieval takes those long-term memories, puts them back into short-term, and allows us to, think about them again. But let's go into more detail about each one of these three kinds of memory. So, like I said, first you have your sensory memories. So sensory memory stores pretty much an exact copy of incoming sensory information, but only for a few seconds. So most of the time we don't really notice this sensory memory. It's so brief, it just kind of comes and goes, and we never really even notice it's there. Another reason why you never notice it is because we're constantly getting new sensory information that kind of overwrites or just replaces our lingering sensory memories. But this definitely does occur for all of our sensory systems. And here's a way that you can experience what sensory memory is all about. Just, at some point, maybe right now, just immediately close your eyes and cover your face. You'll notice, if you do it very quickly, and you could do it over and over again like I am right now, if you do it very quickly, you'll notice that every time you close your eyes, it's not like immediately everything goes black. Every time you close your eyes, the world kind of just starts to fade quickly. You can still kind of see something, even though your eyes are closed. That thing that you're seeing, that's memories that are stored inside your sensory systems, basically. And by paying attention to, any particular piece of information in there, that will allow you to transfer it into short term. Now, you'll know it's in your short-term memory if you're consciously thinking about it. If you are aware of what you're thinking about, that's short term. So right now, if you're paying attention in this video, then this video is in your short-term memory. But things only stay in here for about 12 seconds. So if you want to keep these memories for longer, you're going to have to try to do that encoding I mentioned. But just before we get to that, one other thing I'd like to say is, I mentioned in the beginning that we talk about memory in the same way that we talk about computers. Like these modern theories and ideas about how memory works in humans was developed largely by computer scientists. So if we were to extend that kind of computer metaphor, we could say that short-term memory is very similar to computer RAM, random access memory. The function of computer RAM is short-term storage of memories that are related to what the user, you when you're interacting with a computer, what the user is trying to do. So every time you type something in, every time you copy a file, it goes through short-term memory first. But the problem with short-term memory in humans is that it is very sensitive to interruption or interference. So just think back to the last time you were trying to remember somebody's phone number or something. If you're sitting there repeating the number over and over to yourself and then something distracts you, that memory is going to be gone in an instant and you won't be able to get it back. But if you ever do that kind of memory rehearsal that I was just talking about, now you're taking advantage of like a subcomponent. That's that working memory. You can call it a mental scratch pad. And if we extend this computer metaphor, we would say that the working memory is a lot like a CPU, the computer's central processing unit. That's the CPU, if you're not familiar with computer science, is the part that you have the most direct control over. So as the user, you are going to be influencing your computer through that CPU primarily. Now, of course, long-term memories, those would be the most similar to a computer's hard drive, a computer's storage. Everything you save onto your computer is written onto a hard drive. And a hard drive is basically a disk. It's technologically speaking, it's not completely different from a record. If you know how a record works, the way the record works is that whenever you write onto a record, you create these tiny little physical bumps and things all around the surface of the disk, so that when the needle goes across the disk, it'll bump up and down, and depending on how it bumps, that will tell you different kinds of information. That's exactly the same way that a hard drive works, except the needle is virtually microscopic and the disk is really thick. So there's a lot of information you can store onto a single hard drive disk. And as I said before, if you can get something into long-term memory, it's basically going to be there forever. Basically. To just give you a little bit more detail about short-term memory's limits, I already told you that you can only store information in there for about 12 seconds, but you can't store an unlimited amount. You can only store a small amount of information in short-term memory. The magic number, is what we like to say, is about 7 information bits, plus or minus 2. So it's 7 plus or minus 2 information bits for about 12 seconds. Now, an information bit is just a meaningful single piece of information. It could be a number, it could be a color, a shape, a letter, but it's definitely about 7. And that should make a lot of sense if you think about things like home address numbers. They're usually around 5 or 7 digits. And then you also have things like telephone numbers. Those are, 7 digits. And license plate numbers. And all of these different important numbers in our lives are almost exactly about 7. Because, as I've already said, that's like the magic number. That's the number that most people are able to remember with relative ease. But everybody's a little different. So we can test your short-term memory capacity by doing a digit span kind of a test. So here's how that would work. I'm going to show you a series of numbers on the screen in just a moment, and give you a short amount of time to just quickly look through the numbers and try to remember them as best as you can. Okay? So as soon as you see the numbers, just try as best as you can to remember them. And then immediately after those numbers disappear, see if you can recall. See if you can retrieve those numbers. Okay? So here we go. Here's the first set. All right. Do you remember the numbers? Here they are. So you probably got it, right? And that's relatively simple. Most people can get this 5 digits correct. If you don't get these 5 digits correct, then you're definitely below average in terms of short-term memory capacity, but there's nothing wrong with that. You're not a bad person or anything just because your memory isn't as, fully developed as others. Now here is 7 digits, and most people should still be able to get this. Do you remember? How many did you get right? At most, like I said, most people can get about 7. So this should still be doable for you. Now here is hard difficulty. So this is 9 digits. But remember, I said the magic number is 7 plus or minus 2. So most people should still be able to do this even though it's relatively difficult. So here's 9. Okay, so just count up the number you got correct. And if you can still do this perfectly well, if you're still not having any difficulty, then here is where most people are going to fail. So this is 11 digits. Yeah, that probably didn't work out too well, did it? Most of the time, when people try to remember more than their capacity, they actually do a lot worse than they would otherwise. So what I'm saying is, when you only try to remember 7 numbers, you probably got them all correct. But when you try to remember 11 numbers, which is what we just had, you probably can only get like 4. So your capacity is actually going to be diminished because you're trying to cram too many digits. You're trying to cram too many information bits into your brain, and it just doesn't fit. So if you did remember any numbers, you probably remembered the first few and the last few. The ones in the middle probably got lost. But if you remembered all of these, if you remembered all 11 digits, then you are definitely above average in terms of short-term memory capacity. Now earlier I mentioned that you have that subcomponent of short-term memory that's called the working memory, and that's what allows you to rehearse things. That's what allows you to do what's called maintenance rehearsal, and all maintenance rehearsal is going to do is allow you to keep information in your short-term memory longer, to just kind of refresh its presence in the short-term memory. But as I said before, this is not going to result in permanent memory storage. It's not going to be very resistant to things like interference. So as soon as something distracts you, that memory is going to vanish. So maintenance rehearsal is a terrible way to try to create a permanent memory. When you try to use maintenance rehearsal to, kind of just cram things into your long-term memory, we would call that rote rehearsal or rote learning. Examples of this would be just like repeating the definition of a term over and over to yourself, or repeating some important fact over and over to yourself. So if you're trying to study for the next test, and the way you do it is by simply rereading over and over and over and over the notes, that's not a very good way to study. In fact, that's pretty terrible. It's not effective at all. So you don't want to just repeat things to yourself and hope that they stick around. A much better way to store memories is called elaborative processing. So elaborative processing allows you to do that encoding I was talking about earlier in a much more efficient way. And here's the basic idea about how elaborative processing works. So what you need to do is you need to associate these new memories that you're trying to create with stuff that's already in there. I like to talk about this metaphorically. What I like to say is, imagine that your memories are like a big ball, and if you try to stick something else into this ball, it's not going to fit. It's just going to, there's no place to go in, right? You can't just cram it in there. So instead of just trying to cram a new memory into this big ball of memories that you have to find a place to hook it in. You have to find a place to stick it on. You need to find something in your memory that you can hook in this new memory, to attach it, to relate it. So whenever you're trying to remember something, whenever you want to create a long-term memory, instead of trying to force it in there, simply take a moment and think about, what is this new memory, how is this new memory related to something I already know? How can I attach this to something I already have up here? To put it more simply, whenever you're studying for your tests, you should ask yourself, how does this new information relate to me personally? Can this explain something about my life? Can this explain something about my friends, my family, my interests? How does this new information relate to me? And when you do this kind of elaborative processing, you're definitely going to be able to store long-term memories much more efficiently. And I mentioned earlier that long-term memories are basically permanent. Once you put a long-term memory in there, it's going to last virtually for the rest of your life. But that's not entirely true. Whenever you do this elaborative processing, whenever you attach a new memory to an old one, you always run the chance of creating significant alterations in your old memories. So what I'm saying is, every time you put something new in there, it could change what you have in there. And this could result in the production of a false memory or a pseudo memory, which are, simply put, inaccurate memories that a person believes are accurate. Now, the thing about pseudo memories, the thing about false memories, is that the vividness of the memory is not at all an indicator of its accuracy. So if, for example, you can very vividly remember the way somebody treated you last week, or you can vividly remember something from your childhood or something like that, that might be a very compelling memory. It might be very believable to you and others when you describe it in detail and things like that. But what I'm saying is, that doesn't mean much. You could be completely wrong. You can have completely wrong, detailed, vivid memories. And one of my favorite researchers, Elizabeth Loftus, has proven just that. So if you want to see more about how people can be so dead wrong about things that they believe so strongly, you should check out these links. So I've included a few links to a few short videos about how these pseudo memories are created and believed. Now, you have two basic kinds of long-term memories. You have declarative memories and non-declarative or procedural memories. So declarative memories are memories that you know. They're explicit memories. And that just means these are things like your memory for facts, like what is the definition of the word cat. So that would be an example of a semantic kind of a memory, a memory of impersonal facts. But there's also episodic memories, where now you're just kind of remembering things that happened to you, like what did you have for breakfast, or where did you go for dinner last night. So those are declarative memories. But you also have non-declarative or procedural memories, and these are things that you don't always know that you know. They're implicit. These would be things like long-term memories for motor skills, like how to ride a bike, or how to cook an egg, or something like this. So you don't necessarily need to think about these things, and if you try to explain to somebody how to do these kinds of things, you might find it difficult because, as I just said, you don't really think about it. It just kind of happens. Now, if you want to measure your declarative memories, if you want to measure specifically your semantic memories, those are those impersonal facts, like the kinds of stuff that you're going to be studying for, whatever test or whatever. You can measure how well you know this information by using one of 3 different kinds of processes. You can use recall. So recall is the direct retrieval of this kind of information with the minimal amount of external cues. As a instructor, as an educator, we use recall in our classrooms all the time. Whenever you are required to write an essay, or whenever you are required to write a paper or something like that, those are recall style examples. Those are recall style tests. So the next time you take a test and you see like a short answer or a fill in the blank, that's basically a recall style, because they're giving you very little to work with and expecting you to just basically pull that information out of your memory. A far more common kind of memory measurement technique that is used nowadays, and most students prefer, are recognition style questions. So recognition just refers to when you have the student or you have the individual try to recognize information, try to identify information that they have previously been exposed to. So usually this is easier. It's easier to look at something and say, hey, I remember that, than to simply try to pull it out of your memory with very little assistance. So when it comes to college, when it comes to education, the way we incorporate this recognition style measurement of memory is through multiple choice tests. So the next time you take a test and you have, to pick A, B, C, or D, that's exactly what that is. They're just testing to see if you can correctly identify information you've previously been exposed to. And then the third one would be relearning. So relearning is something we can't really use in the classroom, but you can definitely do it with on your own. So here's how you do relearning. You just time yourself. You see how long it takes you to feel like you've mastered some kind of information. So just when it comes to taking the next test, just start the clock, start studying, and when you feel like you're done studying, when you feel like you know this information very well, stop the clock and see how long that took you. Then do it again. Come back later, time yourself again, see if you've gotten any faster. If you have gotten any faster, then you have what we call a savings score. So then that's the amount of time you've saved on the second time you've studied. And if the score is lower, then that means you didn't have to relearn all this information over again. That means that you do have some of this information in your memory. So the lower the score, the better your memory is for that subject. And if you have trouble remembering things, if you have trouble getting those long-term memories back out again, there might be a few reasons. One major reason is encoding failure. In other words, the reason you're having trouble remembering whatever it is because you never really created that memory in the first place. Obviously, you can't retrieve a memory that was never encoded. So if you're trying to remember something, it might simply be that you never really got it in there in the first place. Another major reason is storage failure. So it's not good enough just to encode that information. It has to be stored well. It's known that if you put memory into your storage and you kind of neglect it, If you don't ever retrieve it, if you don't ever think about that memory, over time it will fade. So memories that are just kind of left in storage and never accessed will fade. They'll decay due to disuse. And then finally, another common reason why people might have trouble remembering things is retrieval failure. So this is not related to poor encoding, this is not related to poor storage, it's just for whatever reason, even though the memory is in there, even though the memory is available, for whatever reason it's not accessible. And this can be very frustrating. It can be extremely frustrating when you know that you know something. You know you have this long-term memory, you just can't find it. It's almost like you're in a huge warehouse where each crate is a different memory. And you know you put a particular memory in there. You know that there is this crate somewhere in this huge warehouse that has that memory you're looking for, but you just don't have any idea where it is. So you'll just kind of be mentally wandering this warehouse, just looking and looking and looking, and you may never find it.